Hello everyone, today we are going to talk about tellurium hexafluoride. And without further ado, let's get started. So first off, let's talk about its property first. Let's start with extensive properties. Tellurium hexafluoride is mostly exists in a gas state, and it has 241.59 grams per mole as its molar mass. Next is its intensive property. Tellurium hexafluoride has melting point at negative 38.9 Celsius and boiling point at negative 37.6 Celsius. It has a repulsive odor and is denser than air. It was a toxic gas that will irritate respiratory tracts of living things. And also this molecule is colorless. And now moving on to chemical properties. So when tellurium hexafluoride reacts with 6 water molecules, it will give us telluric acid and 6 hydrogen fluoride as a product. And also, when these molecules have its temperatures below negative 38.9 Celsius, tellurium hexafluoride will be condensed into a solid. And also, tellurium hexafluoride can be decomposed in water. And now moving on, reactivities. Tellurium hexafluoride is chemically inert. It's not very chemically reactive. Fact, tellurium hexafluoride is a byproduct of ore refining. And the usage of tellurium hexafluoride is that it's mostly used as a chemical reagent. The total valence electrons of tellurium hexafluoride is 48 electrons, coming from tellurium 6 electrons, and fluorine 7 electrons, and fluorine has 6 atoms. So we multiply 6 by 7 and plus 6, and we will get 48 electrons. The lone pair electrons of tellurium hexafluoride is 18 pair electrons.
So moving on, I'll be talking about the formal charge. So to calculate the formal charge, we need the total number of valence electrons minus the non-bonding electrons minus half the number of the bonding electrons. So for tellurium, it would be 6 minus 0 minus 12 over 2, which would give us 0. And for fluorine, it would be 7 minus 6 minus 2 over 2, which would also give us 0. So we can conclude that the formal charge of this molecule is at 0, meaning that it is at a preferable structure. Next, you can see from the picture at the left that the tellurium hexafluoride is an octahedral structure at bonding angle at 90 degrees. And it has 6 single bonds where 2 of the 6 single bonds are a little bit shorter at 1.86 angstrom, and the other 4 is at 1.87 angstrom. For the polarity, the bonding of the tellurium hexafluoride is polar covalent bond, but for the molecule, it is a non-polar molecule. Moving on, as you can see the picture at the bottom right, you can see that tellurium is the center atom, as tellurium has a lower electronegativity at 2.1 when compared to fluorine, which is the surrounding atom at 4. So the condition for tellurium hexafluoride would be an expanded octet, as the criteria for it to be an expanded octet is that firstly, the center atom must have more than 8 electrons. So for tellurium, it has 6 single bonds attached to it, meaning that the total electrons it has is 12, which is more than 8 electrons. And for the second condition is that the center atom must be located more than or equal to period 3 in the periodic table, in which for tellurium, it is located in period 5, so that it adds up to the reason why it is an expanded octet. Thank you.
Thank you for listening. I hope you guys enjoyed. Bye-bye.